So I open your molecule file, input file. So optimization. So we have you didn't change the name here. Okay, no problem. Set AKT. Okay. So perfect. So you will see that in the compounds, okay, the molecule that was given to me by Arthur is planar. All the third column is 0. And it's purely planar with 0 that 0, 0, 0, 0 always. That means that in Gaussian, it will see a symmetry, a planar symmetry. So if we optimize here, it will try to optimize a fully planar. Okay. So we'll start like that, and I will show you what it can give. Okay. And I will show you how we can break maybe. Okay. So what I would like, or what I hope, is that you have some mistakes and something bad happen, so you can learn from errors. Okay. Okay, seems fine. Just wait. No. Okay, perfect. I know that there is a little problem. How did you manage to get your molecule, Arthur?
It was part of my experimental project.
Okay, so it's an X-ray diffraction data? No? How did you?
No, I just wrote it in ChemSketch.
Okay. So it will crash, but it will crash quite soon, and you will see, and I will show you what will happen. Oui.
Les résultats de DRX pour obtenir notre fichier.
If you want to use X-ray diffraction as a starting input, you can convert, or you can. The best is to use, for example, diamond, to open diamond, and you isolate your molecule from your X-ray data, and you can save it as a .mol. It is a way. Okay, so I've launched the calculation of Arthur, and he failed directly. Okay, so we have in the QStat an error, but he managed to get a log file. Let's look at the log file and tell me if you can guess what is happening. So the error is at the end. So what is the most important line here?
The combination of multiplicity 1 and 105 electrons is impossible.
Exactly. So you ask him a singlet state, and he doesn't manage to get it. So there is at least some quality control. If you have a complex and you start with a singlet, and there is an odd number of electrons, he will say, I can't do that. Okay. So now I will show you the input file and you can predict that there will be a problem.
You said it is because it is planar.
No.
Do we have the blank line, the last line is blank?
Yes. So, Arthur, Corentin, and Tony,
Yes.
are you sure that the atoms that you've given me, the structure, correspond to the molecules that you want?
I'm pretty sure, yeah.
No. What is the chemical formula of your compound?
C27 H how many?
We don't have H.
H17 F and 2.
We don't have H here.
In the list, there is no hydrogen.
Oh yeah. Yeah.
So there is when you draw a structure, many times the hydrogens are implicit. In quantum chemistry, it cannot be. So you need to provide the position for the hydrogens also.
Okay.
Rania, do you have that CIF file?
No, I have a point Y.
You have a what? There was a lag. Can you write me the extension that you have in the chat? Meanwhile, William, Liam, and Ellie, you're working on your input?
Yes, we don't have the hydrogens neither, so we are adding them.
Perfect. And Theo, Rana, and Coraline?
Yes, I try to convert in X, Y, Z on openbabel.
And try, that mean that it's not working?
Yes, but I don't know if I the right
input file or output?
yes.
What do you have as input file?
Input the ChemDraw molecule
Okay. Alors, ChemDraw.
point mol.
Okay. So with a ChemDraw, if you have a .mol, okay,
Yes.
you should be able to convert it to XYZ.
Okay.
But try to open it after with a text edit to check if there is the hydrogen atoms. And I'm not sure that when you save the ChemDraw, what I see is that when you copy the ChemDraw to the Chem3D, it had the atoms, the hydrogen atoms, but when you check
Yes.
Okay.
No, I have not hydrogen atom.
Okay.
Okay.
So ChemDraw and ChemSketch both neglect or put implicit, And beware, when you copy from the ChemDraw, you will lose the third dimension. You will have the molecular in the same plane. Okay? Rania, XY or XYZ? Can you edit with the text edit and see what kind of information you have? Okay, XY file. Okay. Okay, so that means that you have the it's the raw data. You need to have the resolution. So maybe the XY can be treated by diamond to generate the SIF, but the best is to have at least the SIF.
Sorry, do we have some analogs of Chem3D if it is not working?
Free analogs of Chem3D. I'm not sure that you. Yeah, maybe Avogadro. So Avogadro is we have two types of Avogadro and Avogadro 2, and you can manipulate a structure with Avogadro. You can fabricate your compound, and you have for Windows, I think that the last Molden and Molecule allow you to draw a compound. No, this is okay.
They are open source or not?
Molden is an what kind of yeah, Molden you need to register as a user, but is it's an educational educational license. I use Molden for Linux, and I use the older one. But I'm if you don't have Linux,
I'm on Windows. I suppose I have some problems because like I have not so recent version of Chem 3D, but
okay.
C4 process.
So here with Avogadro you can draw, but I'm not sure how much you can draw. Yeah, okay. You see, with Avogadro you can draw compounds.
Can I paste simply from ChemDraw?
I'm not sure.
Okay, maybe I'll try to reinstall Chem3D, but I don't know what to do with that.
Um, it seems that Avogadro can open a CDX, but I'm not sure how, if he really have the information. So you can use maybe Avogadro to generate your 3D picture, and you can save it directly in XYZ.
Okay. Then I don't need to use bubble.
Exactly. And
Avogadro is free. Not free.
yeah, yes, it's open source.
Open source. Okay.
And you need to find the Avogadro 1 point. Yeah. So you can have Avogadro in the avogadro.cc.
Okay.
And with him you can generate your 3D version.
Will it be okay because like you tried and you can change the distances? Will it make the proper distances as needed to optimize them like somewhere?
It seems that you can do some molecular mechanics in Avogadro. Yeah. How? But it's not the same as a real quantum mechanics calculation. Okay.
Okay. So I can use these values, but they will need some additional optimization, maybe by a class.
Yeah, that means that when you've done your drawing, if you do some molecular mechanics, it will try to have normal distances, and I think that it's correct to start with this kind of input. If you have X-ray data, it's even better because you have the packing effect. You have a real experimental distances. But for example, in X-ray, many times you don't see the hydrogens. They are you don't have enough information to really get the hydrogen, and they are placed, and the distance between the chemical the atoms and the hydrogens usually are not correct. So even if you have an X-ray diffraction, you have some steps. The thing is that if you're far from the ground state, it will take you longer, and maybe you will not find the real minimum. But anyway, the main problem is that you don't want to lose too many time to go to your global minimum or local minimum. And if you have a molecular mechanics, and if the optimization of the molecular mechanics works, that means that your structure seems reasonable, and it should ensure a better convergence.
Okay, so it is better if I have like X-ray, but with X-ray I'll have to do some work also.
Well, for example, you see Rania has a raw data of the X-ray, but you need to process the X-ray diffraction patterns to have a cell and the atomic positions, and to place them, and so you need some work. Usually when you have done X-ray, there is, like for example in Moltec Anjou, Magali or or some body that is autonomous in this kind of processing, and you have that CIF file. That means that you have already the crystallographic information file, and with this CIF file you have the position of the atom respective one to the other, and you can export them to XYZ. For example, Avogadro can open CIF file also, it seems. Yeah.
Okay, so I need to have CIF.
It's not you need. You need information. It can be X-ray diffraction if you have it. But you cannot crystallize all your structures. Many times you don't have the crystallographic information.
I understand, but if I get it, it needs to be worked on, and then we will get this CIF file with the data we need for calculation.
Yeah.
Okay. But the raw data of X-ray is not useful for direct calculations by
No.
Master.
No. No, just when when you have your raw information, maybe you have half molecules depending on the position of your molecule. If you are in a symmetry element, okay, you may have only half a molecule that is crystallographically independent. So when you open with diamond some raw data, you don't have always the bondings, and you don't have all the atoms. So you need to reconstruct a molecular approach, and for this you need a full resolution of your crystallographic data.
Monsieur, j'ai une question.
Oui.
Une fois qu'on a dessiné la molécule sur ChemSketch, qu'on l'a convertie en coordonnées X, Y, Z et qu'on l'a remis sur votre fichier OPT, là, on peut vous envoyer ou il y a autre chose à faire?
Non, c'est parfait.
Ok, d'accord.
Un petit nom et puis voilà.
Ok, d'accord.
Yeah. Perfect. Oh, I haven't seen the new text file. Ah. I'm not sure that you've selected the XYZ position, Arthur, because there is a Z. If I give Gaussian 5 column, I'm not sure that he will understand which one is which.
Sir,
Yeah,
we need the XYZ or the XY?
XYZ.
Okay.
You need the atom symbol, a column for the X position, a column for the Y position, and a column for Z position. Okay, so the Artem compound, Artem and George compound is running. So the time use is 4 hours because that's half an hour per processor. AKT is working for 3 minutes and the DPP is running. Okay, and we have ELW Truxen. Okay, perfect. Hop. RML ou IL, oui, ok. MK dire IL, oui. MK dire Truxen and Truxen O. O. Okay. Let's look at your input. Okay, so you change your basis set. I think that it's really what do you want with Truxen? Do you want excited states or not?
Yeah, we want well, we want the excited state, but first we just want to see the ground state.
Okay, yeah, your basis set with only one D function is if you use 631 plus GD is the minimal basis set for excited states. Okay, and you can for example, when you do a full LSN or something that more with twice as many atoms that you have, I think that right now we can add a little bit of polarization if you want, or we can start to look at the ground state, and when you have the ground state already, you can converge to with a better basis set that will be used later on for your excited states. In terms of time, it's better to start with a small basis set, but that means that you need to remember that you have more steps. That's all. We can compare. Let's see. We will use your basis set and we will see how faster you get corresponding to other groups with similar or with more or less the same kind of atoms. You've forgotten the blank line in the end.
Again?
At least for the Truxen.
We have to send it to you again, or?
No.
Oh, okay.
Just that your job was not complete. Okay, so now everything is running. Akate, it's a new file, Arthur? What is the difference between what I've launched right now?
Yes, I put the molecule in a 3 dimension in ChemSketch, so I have all the Z positions.
Okay,
Atoms.
perfect. Okay, so let's see what is happening. Okay, so we'll look at the position of the atoms. So to search for information in Linux, it's much more convenient than in Windows. There is a command line that is called grep. So it's like a find in a Word, but it works without opening the file. That means that you don't have to open in Word your log file, and the log file of calculation can be several thousands lines of outputs. So you can do and search for keywords, and it will only print the lines that corresponds. So we will learn a little bit of that during our exploitation of the data, and I will give you a synthetic. Last year we've made a slide with the different grep that I advised you. Okay, so we will look at the slide again either today or next time. So grep done. Okay, and we look at the energies, and it didn't converge any geometry right now. He's still in the first. Ooh. He's still in the first cycle. Okay. We'll compare. So I make a new directory. Model 1 3D. You didn't put the blank line? Okay, so the last group that we need is Rania, Safia, and Abdul Majid. I suppose that Rania is working on it. As you wish. as you wish, no problem. The thing is that next week you have Denis' class, and I think that we'll see each other. Yeah, not next week, but the week after. So the 24th of November, and it will be great if the calculation have time to go up to the end, so we can start to do some exploitation of results. Perfect. So as you wish, or if you want, you can even you can even try to do some artifact pre-optimization, as you wish. You can send me by mail your input files when they are ready. Meanwhile, what we could do is to look at errors that previous years have encountered. So I'm searching for error termination. Perfect. Okay. So instead of normal termination, we have an error termination. The thing is that, okay, I think that some of your comrades just deleted some of the errors. Okay, perfect. Okay, so I will open some of the files and you will see. Okay. That's enough. So just here you can see that this compound, the log file is 460,642 lines. That means that you don't print an output file of Gaussian. and in the end it crash in this part. Okay, you have an error termination in NTR ERR, and you have NTR R called from file EO. You have some strange numbers. Okay, and here you have again the file EO. Do you know what in computer language, what does that mean, file EO?
Input output.
Yeah. So here we have a problem of file input output opening files. That it tries to open something and it fails, and it puts an operation on file out of range. If that happens for you, you have two main causes in Gaussian. The temporary file has been removed, or the disk that he was searching on. That means that, for example, here in our cluster, the computational nodes use the central hard drive, and sometimes if there is a copy or there is some operation in the hard drive, when Gaussian asks to write on the file, the master say, wait a minute, I'm busy right now, and Gaussian is quite problematic. When he wants to write, he needs to write. If not, he crashes. So this is a problem of limitation. And the other possibility is that he's trying to do something in the geometry that leads to an incoherent geometry. For example, when you have a line of several atoms in the same line, there is a dihedral angle that are zeros, and it doesn't manage to get the XYZ correct. Not the XYZ, because he's not working on XYZ. He's working on relative position, and when there is, like, for example, 3 atoms in a row, he has an infinity, because he's dividing by 0, and he makes that there is a relative position with an incoherent number, and sometimes this is enough to make Gaussian crash. So here I'm just showing you what can happen. If there is a problem, you can ask a specialist, okay? But if you could at least try to understand before calling a specialist, because sometimes the answer is explicit. Okay, you see here there is error, NTR. Here, error termination with link apply G09 L502. You have the same here. Okay, so here, what do we have? And I would like that it's not Rania and not Artem that try to answer this question. So there is a little bit more participation from the others. And you can try anything that you want. Okay, there is no evaluation no judgment. If you have never done some calculations, you will probably think that maybe something happened and it's not the case, and there is no problem. What I would like is some kind of participation, and I will at least understand how you read the text and what is your representation, for example, of a calculation. So here we have a message of error. So the answer is not in the line error termination, okay? Because this part is more obscure, but you have some kind of information before.
Is it about the convergence criterion?
Yeah. So what kind of convergence and what do you think that is going on here?
What is annihilation of the first spin contaminant? What is annihilation?
It's a good question. However, you've done. Let's see what you've done with Denis.
How to understand that I don't understand fully what was in these formulas. I try to understand the overall.
Yeah. The fact is, if I find some formulas that are dependent on the spin, at least I can illustrate the formula in a new context that will allow you to understand a little bit more. But I'm not sure that he has treated the spin contamination right now. So for example, if we take the couplet cluster approach to get a better picture of the ground state, we've seen that if you put more ingredient in your approximation, that means if you put more functions, it can provide a better picture of your ground state. And for example, you can put some part of the excited states to compensate the errors of your initial ground state. That means that you will try to get more a Taylor expansion, and you can add, for example, simple equation, excitation, double, triple, so on, and that means that adding a little bit of excited state characters can allow for a better ground state description, not because that in your reality you have excitations occurring, is because our ground state is not fully reproduced with our approximation, and the error is not in the same order or in the excited state. That means that you can, for example, in our ground state for artery fork, you have sometimes something that is too covalent. So if you had some excited state character that is anti-bonding, you can compensate the overbonding of the ground state. So it's more a mathematical approach. It's not really that our H2 is excited in the theory. It's that we use a part of the excited state to get a better picture of our real ground state. And
Where we get this part of excited state.
so it's the method. For example, here, if you want to do that, you don't use Archifoc, but you use a couplet cluster approach. And the thing is that when you do a pure ground state, you are waiting for a spin, d'accord? And sometimes the calculated spin is not perfect because we have incomplete integrals, or we have cut some integrals in the space, and sometimes we don't have fully 1 electrons or 2 electrons in the orbitals. And when you add all this, you can have a polarization of spin. That means you have like a pseudo-paramagnetic compound state, but not fully. And that's what we call the spin contamination. That means that we don't have full spin states, and you have always a check in this. So I think that Denis will talk about it, and I will talk about it later on. So we'll come back to that. The answer here of the problem is not the spin. The answer is indeed the convergence of the wave function. And it's not a convergence of due to the spin, it's just that it don't manage to minimize the energy of your geometry, and it doesn't manage to get a correct wave function with this geometry, even after 128 cycles, and this is by default the limit. So probably there is something bad happening here, or the geometry is really bad, or you have something that makes the calculation harder, and Gaussian cannot converge. So each time that you see an error termination with the L102, it's a convergence problem of the wave function. When you see error termination link 9999, this is the last link of Gaussian. It means that he has done everything, but he thinks, or he has indication that the calculation leads to something that is not fully correct. That means that for him, usually when you do an optimization, the convergence criterion were all not optimized. That means he has, for example, 4 criteria, and he has an optimization in 2 of them, and not the 2 other. He doesn't manage to get better, so he stops, and he tells you, okay, I think I'm here, but I'm not sure. And so he stops, and he doesn't say normal termination. He say, be careful, okay? I'm not sure that I land on something that is what you're looking for. If you have a problem in the number with the L number, so you see it's incremental. If it's L100, L200, L300, L400, there is a problem in your definition of the of your compound. So 100 is the geometry, the parameters. 200, 300, and 400, it's all the parameters. So if it's crashed before the 500, that means that it didn't do the calculation. There is a problem in your input file. Okay, I was searching for 300 because it's the basis set. 400. Perfect. Truxen. So when I do grep down, I see down, that means that he has finished one geometry. So I can start to look at the geometry with Molden, for example, or Avogadro, or Gauss-U, but it's not a free program. Let's close this one. So the Molden that I use here is really an old one. It was old even when I was a student. Okay. So so this is the compound that okay. Okay. So you see, this is the geometry that correspond to the Truxen input. That means that the carbon-carbon distances are quite low, 0.9. So for him, it seems that it represents quite a huge energy in gap. So probably it was not optimized with molecular orbitals. And there is one more problem: it's totally flat. And but I think that probably maybe Truxen is flat because you have a benzene, a 5-member rings, a 6-member rings. What is this hydrogen? The thing is that here the distances are really bad. I'm not sure that Gaussian will manage.
Sir?
Yeah.
Is it normal that all the hydrogens are reunited in one point?
No, it's just that here this hydrogen, if you look at the distance between all the atoms, technically he see that the distance here and here is under a chemical bond with the van der Waals radio. here also, here also, here also, and here also. That means that this hydrogen is bonded, chemically bonded to all those carbons.
Okay.
So your first starting geometry is bad. That means you have atoms that are too close to each other. So I'm not sure that it will manage to converge to where you want. Okay. So if you can add some kind of optimization or have a better atomic distances, it will be better.
And how do we do that?
What did you do to draw your compound?
I used ChemDraw.
ChemDraw, and you don't have a Chem 3D?
Oh well, actually I don't know. I must check. Can add 3D property.
No. In ChemDraw, when you had a 3D property, it's not the same as a ChemSketch is free. Or maybe what you can do is you can open your CDX with Avogadro. You download Avogadro and you try to have something that is in 3D. Okay, and with some kind of molecular mechanics optimization. How did you do the ChemSketch is this one with your builder that you've tried to do?
I've used ChemDraw.
No, the it's Arthur that made that managed to get a 3D.
Yes.
Is
It was that one. It was,
okay.
that one.
So it seems that if you don't have Chem 3D, you have in ChemSketch you have a 3D builder. But Avogadro should work fine also.
I have an option on my ChemDraw. It's get 3D model. Is it?
Try and you can see.
Okay.
Actually, I tried in ChemDraw. We have an option like Chem Bio 3D link, and I can't optimize the molecule, but I can save it in like Chem 3D or in MDA file modify.
So I don't know all the programs. What you can see is if you cannot manage to save your compound in a XYZ file, you can try to see if your export file can be read by openbabel, so it can generate in turn the XYZ. That means that with openbabel you can use other files, MDL maybe, so you can use a new sketcher that you've used previously, or anyone that you, depending on what kind of information you use, and maybe you can generate a 3D compound. openbabel can also do some molecular mechanics. That means that if you okay, let's see. CDX ChemDraw.
Well, actually, I just looked on my on my folder, and I have ChemDraw 3D.
Okay.
If you want, we can draw again the molecules and send it to you.
Yeah. So you open with Chem 3D, you do a molecular optimization, and you send me the new input files.
Yeah, the new coordinates.
Yeah.
Okay.
I'm trying to see if I can open with the CDX. If I can open the CDX with start import delete hydrogen. You can input up test. Delete hydrogen, add hydrogen, center coordinates, generate, and you can generate 3D coordinates. Let's try to, can you do XYZ? Ah, okay. Add hydrogen. Engine 3D. Convert. Oh! So if you have a CDX from ChemDraw, you can leave the generation of the 3D coordinates to openbabel. So he is able to generate 3D coordinates with molecular mechanics. He is doing an MMFF 94. Maybe it's not perfect, you don't see it. Contrary, if you use Chem 3D or the Chem Sketcher 3D builder, you can see the coordinates, but at least here you know that the compound is not flat because you have a Z information, and you can generate an XYZ directly like that.
Okay, so I can take CDX file from ChemDraw and directly the bubble, optimize
Yeah.
it, and save it into
Yeah.
XYZ.
Yeah.
Uh-huh.
So what I encourage you to do is later to open the XYZ with Avogadro, if you can, to see the molecule, how is it, how it renders. Okay.
How it was optimized.
Yeah.
Is it correct?
Yeah, because I've sometimes I've used the molecular generation of openbabel, but it really depends on how he reads the CDX and the binary camdraw. I don't know if he really understand well the 3D coordinates. You see, I've put something that this oxygen and this carbon is. I didn't give him the information if it's in the upper or lower part. That means if it's an M or a P helicity, and I'm not sure how ChemDraw manage, how openbabel managed to get this information. So let's see in Avogadro if it's open. Avogadro, let's see that. I've seen your file, Rania. Okay. With openbabel, you can directly transform a SIF in XYZ, by the way. Okay. Test. Do you understand XYZ? Open. Yes. No. Okay. Oh, it worked. More or less. So you see the generation of the 3D is okay. What is the distance? Do we have a measure? 1.3. Okay. So distances are correct, except one atom that is quite strange. Is this atom? Oh. So here you see there is this one, and problem is here the angle just will to transform this kind of orientation that is more an SP3 to an SP2. Why is it not? Okay, so you see here it's not yeah. So okay, so it works, but it's not perfect. Okay, so let's read. So the others that have done a planar compound, okay. So Arthur, Corentin, and Tony, your compound was also no, it's okay. Your Coraline, Theo, Rana, your compound was planar, if I recall correctly. So maybe it could be wise to do a 3D generation.
Okay.
Okay. What? There's something strange in your atom. In your coordinates, you have tungstens, quite a lot, antimony, oxygens, a lot, potassium, it's a super huge compound, and it's fully inorganic. So I think that there is more than one cell, or when you open the XYZ on diamond, you need to get just one molecule. So good question. Try to let's try what can do openbabel. Openbabel can open a CIF and save a XYZ. Let's see if he is able to generate the molecular compound that corresponds to. But your compound is really 6 tungsten, 1 antimony, and 22 oxygen. So it's an inorganic solid state compound. If it's the case, Gaussian is okay. Gaussian is not okay. Let's see what openbabel do. If you have if you can generate a molecular approach, okay? So you should have something like that. So it's a molecular entity, more or less. Tungsten, antimony 2. You have 2 inner cages? No, 24. What kind of structure you have? You have 2 X. That means that it's a strange Anderson. WMF. Oh, it's 1 SB. Okay. 1 SB. Okay, 22. It's -1. Perfect. What is WMF? Ah, it's a real. It's a paint. Okay. Ooh, wait. Oh boy. Okay. Okay, let's try. So no, it's interesting. It's the first year that someone tried to do a polyoxometalate, and since it's more inorganic, you are in a territory that Gaussian is not the best. However, it's a molecular entity and Gaussian should work. It will not be super efficient, but it should work. It's just that to choose the correct functional and basis set will be tricky, because in an oxide compound you could have a full delocalization of the electrons. And when you do Gaussian functions and when you do an atomic orbital approach, you have localized compounds. And so even if we give him a polarization and diffusion, the PBE1 or PBE0 is a functional that will not allow one molybden to fill the other one. So we need to change the functional to adapt. Okay? Do you remember what kind of functional you can choose to have a long range, super long range distances? Rania or the others? We've talked about it last year, or at least it was in the class last year. Okay, Colin. Ah, pas de tail. Ah, yeah, it was already done. The blank line in the end. Okay. Okay, cool. Okay, so now AKT is already in 3D, DPP is on 3D, Truxen. How is it going for Truxen? Do you manage to get the 3D coordinates?
Yes.
Okay,
We will send you
perfect. Um, I need to see that. I need to see the XYZ. I think that there is only a part of the molecule. Yeah. And this is the problem with the SIF. In the literature, yeah, okay. No, it's not correct. You don't have. You only have the atoms that are independent of the symmetry. So I'm not sure. Here, when we do SIF, crystallographic. Here, when you generate in openbabel, you have this fill the unit cell. Strict or keep connect. Try to do the keep connect. That means that try to do only the what is in the unit cell, and try to see if you generate more compounds, or if not, try the strict. And let's see if you have something that germ bond. In the field unit cell, you have two options: strict or keep connect. Yeah, but without the space. And try to see what happens. Let's see if you have, and you can open with Avogadro later on. Okay. What can you open with Avogadro? Sieve. Oh, you can open a sieve with Avogadro, by the way. Can you send me your sieve file? Mm-hmm. Okay. Shape. So this is a compound. YZ. Pomme. Okay. So convert 13 atom. Oof. 3D geometry. Keep a line. Keep connect. « 211 atomes. Ouch. Non. Non. Il y a plein de répétitions. Ils sont tous au même endroit. Boum. Pff. Bullshit. In your with Keep Connect 88, I don't have 88. Maybe you don't. We don't have the same. It's 3D coordinates. Maybe that is not great. Keep Connect. Convert. Moi j'ai 166, 56. But anyway, the coordinates are wrong. Do you have correct coordinates here? You open your XYZ and you look at the numbers. Mm-hmm. In your in the article where there is calculations, maybe there is the XYZ in the supplementary data. Oh. Okay.
Mercury is for what?
Mercury is a program that is specialized in crystallographic data. And if I recall correctly, Mercury can convert SIF with XYZ, and there is a little bit more options than Avogadro or openbabel. Mercury is a visualization program that is made by the ones that maintain the CCSD, the Cambridge Crystallography Database.
Okay, so with it we can work with crystallographic data, and maybe like if we have the data from X-ray, like this diffraction pattern, we can convert it and use it in our calculation.
If you already have the SIF. Yeah, it seems that this spectrochemical character part 1 does not ask for supplementary data with atomic position. So I will try with the mercury later on, okay, in the evening. You managed to do something? And did you try to open it with maybe Avogadro? Let's see. Okay. Perfect.
Sir,
Yeah.
just to say, we put the new coordinates.
Yeah, I've seen, William. Thanks.
Yeah, also, I see that it's the hour to go. Can we go, please?
Yeah.
Thank you.
So I launched the last calculation that you've given to me, and we will see each other in 1 week and a half, and we'll discuss what is going on with your calculations and how you can extract data from them.
Okay.
Thanks to have been there, and I hope that you will have a good next week.
Thank you.
See you.
Good weekend.
Just a last question.
See you.
Just a last question, just for a group.
Yeah.
If there's any problem